Good morning, everyone, and welcome to Coreflux at Hanover Mess. I'm João Barroso, and I'm here with Surajeet from DataPebbles. He's going to be the first talk in our booth at these sessions. Today we're talking about reference architecture for real-time industrial IoT. And everyone's talking about AI, but no one's saying why real-time is important for AI. And no one's saying what this man has to say. So Surajeet, thank you for being here with us.
Thanks
it's a pleasure. I hope that you can keep bringing your knowledge and your stroop waffles every time we meet.
Definitely, yes.
Yeah? Are you ready to change the world, present stuff?
Always. Yeah, thank you.
That's the one I want to hear.
Thanks.
Ladies and gentlemen, Surajeet, thank you.
Thanks again. Yeah. Thanks for inviting me, Coreflux team here, and I'm very happy to talk about reference architecture for real-time industrial IoT. One of the things we always talk about is AI. AI is almost taking over the world, and agentic AI in general. So AI was last year, this year is agentic AI, but nobody talks about agentic AI. It always works on real time. You cannot expect agentic AI to work on one-day-old data, because if people have to do something, they will always go look for the latest data points. Agentic AI cannot just go and ask somebody, hey, give me the latest data points. The data has to be present in front of them. That's why we need real-time data. So what we are seeing right now, industrial data is missing the foundation. Every real-time architecture always starts with data and data foundation. We found by research that 70% of manufacturers are still stuck with Excel sheets. So they get a lot of data from sensors and devices, but they put in Excel. And then it becomes a manual thing. It's not a foundation you want to expect. Everything should not be in text-based format. The cost of inaction, the lack of modern platforms actually cost us a lot. 74% of the industrial projects do not go beyond pilots. They always stuck this Excel sheet. They prove some point, but then don't know how to scale it, how to productionize it, because it's still somebody's laptop which showcase how it can work. The AI gap, and this is where the real talk for this today is, there's a conflict. This is a report from KPMG this year. 76% of the companies are not ready, or they don't have the data foundation to do AI properly, and that's the biggest risk for agentic AI implementation. But why real-time matters? Real-time helps us in, these are top three, there are more, but these are top three: reduced downtime, improved operational equipment effectiveness, and faster decision-making. How this helps? If you have real-time data, 30 to 50% of your downtime is reduced. 70 to 75%, people have found that already, 70 to 75% of less breakdowns happens. Manufacturers which invest in real-time, they always get the best, like they always stay ahead of their competition. They always find the best solutions to get to their next level. Recently, automotive part manufacturers cut downtime even from 12 to 2 per month. In the report, it mentioned they saved 350,000 over just by reducing this downtime annually. For improved operational equipment effectiveness, as you can see, these are reports from Siemens. Siemens, for their gas turbine, I think, they created real-time platform, and which increased their OEE from 65% to 85%. Industry standards, average industry standards is 85%. Nobody has ever achieved 100%. 100% means every part is good, which is kind of not there yet. But people are, most of the organizations are stuck at 65% right now. But having real-time capacity and predictive maintenance helps you to get 85%. Faster decision-making, of course, real-time data, when it lands to your dashboards, you can make quick decisions. If something is going to break, you can arrange properly. Most of 23% of the downtime actually happens due to manual errors. Why manual error? If you are giving only Excel sheet to your colleagues and co-workers, they can make errors. Error is prone to happen, and that's why real-time really helps. But I'm gonna go over some of the pillars of real-time architecture. This is not a complete story, but I just picked few which can fit the screen also. That's one of the things. One of the biggest component of real-time is streaming data platform. What does streaming means? How the data comes from signals to actual cloud or to cloud providers, your databases. There are 3 points which I want to highlight. You should have a standardized data protocol like MQTT. So how you're passing data from a lightweight protocol from a machine, PLC devices to other softwares. Standardized data model, how you model your data, which is very much mapping towards your business domain, because every sensor depends and showcase or have different kind of data attributes. You have to map it towards your own business model. And resilient data tools. So of course, if you're collecting data from edges, you cannot control what happens at the edges. Internet can go break down, electricity can go down, and you have to make sure that the whole data set is resilient. If a factory is offline, it should come back live after a couple of days. You should have all your data, because you cannot rerun the whole machines again. The data should not get lost. Advanced analytics, how you, once you have the data in cloud, how you can make decisions. It depends on how you aggregate all the data across all the edges, all the factories, how you map it to your domain driven business models, because at the end of the day, you have to make decisions. You cannot just look at factory data fields with match with Python snake case or something. You have to understand and translate towards the business domain where a stakeholder can imagine and understand it. And real-time dashboards, again, go back to the same story. The data should be popping up in the right way so that people can make decisions easily. The last part is, yeah, we are the word autonomous execution. With all the data coming real time, and with now advancement in AI, deep learning models, machine learning models, and even LLMs, you can do a lot. The world has changed more towards action using autonomous agents. And this is all going towards this. The last bullet point is the most important bullet point. Agentic AI needs real time. You cannot expect agents, AI agents, to wait and act upon old data and make mistakes which nobody can even find out why would happen. So if we have to have this, what we need to focus on? This is again not a complete list, but it's kind of goes over some of the key points. You have to think about data stream, so something like MQTT. That's why we are here with Coreflux. Stream processing. So we have when's the data coming out of these devices, how you can process it so that you can just filter out the noise and keep the most important data with you. They are open source Kafka, but you can also use Coreflux Broker. Coreflux has its own, I think, Coreflux Broker Hub, which can go land into the cloud also. You have to think about cloud hosting. Where does the data end up? Either it's your on-prem data center or your cloud provider. Data models, it's a time series database. What kind of storage limitations you have? Where do you want to store, on edge or on-prem or on cloud? Business domain transformations. This is kind of a very key point, because that's where human starts getting involved. And whenever human involves, you have to talk, it goes along, and this is one of the challenges I want to talk about. You have to understand the business domain also, why this company is doing what it's doing. Decision intelligence, then this is the second last layer about how to create intelligent actions on your analytics. So AI-driven machine learning models, forecasting models, predictive maintenance, they are still not LLMs or not agentic, but these are very, very, very useful technologies to help you go to the next level. And then the last is autonomous operations, closed loop system. Why closed loop? Because we are still not there where we can run all autonomous, fully autonomous agentic systems yet. What are the challenges in having some kind of this kind of architecture? Again, this is not a complete list, but we're going to talk about data governance. I kind of squeeze in data governance and security together. Governance is internal. How do you govern who within your company reaches the data, access the data? And data security is also covering how you can protect your data from outside threats. And 3 bullet points I wrote here: who can access the data, that's data governance. What layers of access you can provide, because within your company, you can have multiple departments, multiple access level. You have to think about that already when you're preparing for your data foundation. Encryption at rest and transit. This is very important. With now, world is becoming small in terms of technology. Everybody can reach your data center easily. You have to think about how you protect your data. Information model. like I said, this is where your business starts interacting with the actual PLC devices. You have to think about how I map this PLC device sensor data towards my business goal. And this is important exercise which takes a lot of time, and that's why it's one of the biggest challenge we see in companies. Once they have all the technology proven, they still don't go to production because they don't know where to use it, how to map it, and how to get value out of it. Last one, tech skills is always a challenge, no matter which industry you are in. All these modern technologies bring new learnings, so you have to have a team which is learning all the time, constantly learning, and because technology is moving very fast, it's very difficult to keep up to date. Now, with all this talk, I think we should talk about what kind of reference architecture we think should be useful. This is example architecture from one of our implementations. Few of the bullet points you see: no vendor lock-in, 90% open source, and it helps to, and it's cloud native, so it can run in any kind of cloud provider, which also helps to make sure that you can get values over a period of time, over years and years. Resilient system can sustain isolated failures. If one of the system is down, the software makes sure that when it comes back alive, the data is pushed back and it gets synced over a period of time. On edge, we choose solutions which can also help on-edge data storage as well as on-edge analytics, because in certain situations you want to have decision-making power on the edges, not on the cloud. So your cloud can train the model with all the edges data, then this model can run on edge and you can have some predictive maintenance. Secured, this data is pushed. Where does it help? When your data is only pushed, then the data originator knows where the data has to go. It can allow certain subscriber where you can push the data. It also takes care of cybersecurity in that sense. I think this is my last slide. Thank you very much, guys, for listening. Yeah.